All right, this webinar is officially live. All right, I see a few folks trickling in. Thanks everybody for attending. We're going to give it a few more minutes for more people to arrive. So please hang tight. And we will get started probably a minute or two past the hour. All right, for new arrivals, please hang tight. We are going to be getting started with our webinar in just a minute or two. All right, seeing some more folks entering. So if you are just joining us, thank you so much. Welcome to our webinar on lessons that we can learn from Moss Landing. Really excited to see this attendee list. So let's give it another minute or so to make sure that we can get a few more folks on board. So I can go ahead and set the table a little bit. We have some really great panelists for you today. And our goal is to contextualize the Moss Landing fire incidents within the broader context of clean energy and battery storage and the lessons that we can learn from what happened, what makes the Moss Landing incident such an anomaly in the broader context of California's battery storage industry, and where do we go from here? How can battery storage continue to be a source of reliability as well as community benefits? All right, let's give it just another 30 seconds, and then I will go ahead and toss it to our panelists to start speaking. All right, I think we've got a good number of folks on board, so thank you very much for attending. My name is Jessica Gable. I'm a senior program manager with Sunstone Strategies, and this event today is sponsored by the Reliable Grid Project. I am really excited to introduce you to our panelists today. First up is Dr. Mark Jacobson. Mark Jacobson is a professor of civil and environmental engineering at Stanford University, and in his career, he has sought to better understand the problems of air pollution and global warming while developing large-scale, clean, renewable energy solutions. I'm really excited to welcome Dr. Jacobson.
Thank you, Jessica. So yeah, I want to talk about batteries in general in California and also the specific Moss Landing incident. Just to put things in perspective, California is undergoing an energy transition where it is moving to clean renewable electricity, primarily solar and wind, and then some geothermal and a lot of existing hydroelectric power, but also battery storage. And this is occurring not only on the grid, but also what's called behind the meter. So in people's homes and businesses, there's a lot of solar going up and batteries as well. That's not actually counted in the grid electricity, but it reduces grid demand when people have their own solar on their roof and batteries in their garage. They're using that solar first, or the solar that's stored in the batteries at night. And so you don't need grid electricity. So that reduces grid demand for electricity. And this has actually helped quite a bit to reduce the demand for electricity in California. But right now, there's a huge amount of solar and batteries on the grid in California. Just to put in perspective, like yesterday, for example, the main grid, the California ISO grid in California was over 100% renewable. In fact, it was 130% renewable at one point, and it was over 100% renewable in terms of its demand for over 7 hours. And in fact, last 18 days straight, it's been over 100% renewable, and in 34 days out of 62 in this year so far, 100% renewable, and that's increased a lot. And all this extra solar is because when we have extra solar, it'd otherwise be wasted unless we either stored it or used it or exported it. So right now, most of the excess solar in particular during the day is going into battery storage, and then that battery storage is being used, the electricity is being used at night. There's also quite a bit of it that's being exported to other states when we have even too much to store in batteries. But just to give you an idea how fast batteries have grown in California, they're now overall in California about 13.5 gigawatts, and on the grid about 11.5 gigawatts. So there's about 2 gigawatts in people's homes and businesses. And so on the grid is 11.5. On the main grid, the California ISO grid, it's about around, I think, 9.5 gigawatts now. But just to put that in perspective, the average demand on the main grid over the year, last year, was 24 gigawatts. So the batteries are reaching a big portion of the average demand, but and you can store the electricity in the batteries for about 4 hours. Now, this is really helping at night, especially because when you're storing the electricity during the day, the excess electricity is being used at night after sunset primarily. And this is reducing gas on the grid, fossil gas on the grid. And just to give you an idea of how much gas has declined just the first 2 months of this year, it's declined 28% compared with the first 2 months of last year. And compared with 2023, it's declined now 37%. So we're rapidly decreasing the amount of gas on the grid with the help of solar and batteries. And this is really important to actually do this because California is the most polluted state in the United States in terms of air pollution, with on the order of 12,000 deaths per year. And well, most of those deaths occur in Southern California, the Los Angeles Basin area, and the Central Valley, but certainly in San Diego and other parts of the state as well. So it's really crucial to get rid of combustion fuels, whether they're from fossil fuels or biofuels, because combustion fuels are causing virtually all of these deaths. And also then there's hundreds of thousands more illnesses as well. And so batteries are very crucial for this transition, especially since if we look at what's in the queue on the California grid, and by the way, electricity is only one portion of this pollution. I mean, there's also transportation, buildings, and industry. But grid is a very important part of it. What's on the queue in the California grid is almost all solar and batteries. There's another like 40 gigawatts of solar on the queue and about 50 gigawatts of batteries. There's a little bit of wind, a little bit of pumped hydro storage, a little bit of compressed air storage. There's hardly any gas in the queue on the grid. So what's going to happen in California if everything goes to plan is you're going to have a lot more solar, a lot more batteries, and there'll be hopefully some offshore wind at some point as well. But the batteries are crucial. Now, I should just put the Moss Landing, it used to be a fossil gas facility from 1950 to 2022. It was used to produce electricity from fossil gas. And so you're burning gas, and so there was a pollution continuously every day for 72 years in that community. And so just to put the perspective, the fire that occurred in Moss Landing, which was not good, nobody likes to have a fire, but it's a one-time event versus continuous pollution and health problems for 72 years from the gas facility that it replaced. Now, to avoid, but to put in perspective, battery fires, while they get a lot of attention, they're actually very rare compared to combustion fires from gasoline. So, for example, it's easiest to look at electric vehicles versus gasoline vehicles. So there was a study from that used transportation data from the US that found that there were only about 25 battery car fires per 100,000 battery electric vehicles, but there were 1,500 gasoline car fires for every 100,000 vehicles. So it's much more rare to have a battery fire than a gasoline car fire. And now there are a few isolated incidents of battery fires in power plants. There's one in 2023, for example, and there's this one in 2024 for for Moss Landing. But the part of the reason for this was maybe the lack of ventilation. The reason that most battery storage facilities do not have fires is because they're outside in containers and separated by distance. When they're in a container, then if there is a fire, it's limited to that container, and they would have to jump from that container through air to another container. But they're ventilated by the outside air. In Moss Landing, they're all indoors, and so this allows some gases to accumulate, and that's part of the issue. So better ventilation should avoid future fires. And also the type of batteries, the other issue, the newer LFP batteries, lithium iron phosphate batteries are less likely to catch on fire than I believe the batteries were in this case. But this was like the fire, I think, affected a 300 megawatt battery, and that's compared with 13.5 gigawatts, so 13,500 megawatts on the grid and behind the meter in California. So it's a very small percentage of batteries that caught on fire in California, and so it shouldn't have much impact on electricity delivery. So anyway, I'll stop there, but just point out that I think it's not something that happens very often, something that can be avoided with better care in the future. But we do need to keep going with batteries and get rid of combustion because that's far worse. That's the alternative.
Thank you so much, Mark. Thank you for all of that context. And it's really, really good to know where Moss Landing sits in terms of the broader progress of batteries in California. And it was especially poignant what you said about the 28% decline in gas that California has been able to achieve through
Yeah,
battery.
28%, in fact.
28%, that's amazing. So I'd like to also just mention for newcomers that we are talking about battery storage post Moss Landing fire. And also just to mention one housekeeping detail, if anyone has a question, please hang on to it or pop it into the Q&A box that you see on your screen. We're hoping to save about 20 or 30 minutes for Q&A for our panelists at the end of the webinar. And now it's my pleasure to introduce Dr. Dustin Mulvaney from San Jose State University. Dr. Mulvaney is a professor of environmental studies, focusing on social and environmental dimensions of natural resources, land use change, and global production systems. Dustin, thank you so much for being here.
Great. Well, thank you for hosting this webinar, and thanks, Mark, for those opening remarks. Yeah, so I just want to echo, I think, what Mark said about the importance of Moss Landing itself. It's in a very important part for the grid. It's directly tied into the Pacific intertie. So that particular location is really important for batteries. You know, we do have a lot of renewables in California. Most of those are down in Southern California and you know the Mojave Desert and Colorado deserts and such. So we really need more energy storage in Northern California to be bringing power closer to the urban loads that are up in this region. So, you know, because we don't have the renewable generation capacity yet, you know, offshore wind notwithstanding, down the road. So storage is crucial for retiring the natural gas power plants that still operate when we're generating even on these 100% renewables days. There's, you know, to Mark's point about the legacy pollution, you know, that the early units at Moss Landing actually burned oil in the wintertime before switching over to natural gas. And those are the ones that were in the turbine room where the batteries were. So that particular facility actually, literally in that same building, they burned oil. And the stacks you see there, those came a little bit later. Those were natural gas. And those are retired. They were retired in 2017. And behind the battery systems, there still operates a 1 gigawatt natural gas combined cycle power plant. So in order to retire that power plant, we still have to have more batteries kind of locally to be able to, you know, make up for the reliability that natural gas still provides on certain times of the day. So just want to first point out really that it's a crucial part of the electricity grid there in Moss Landing. It's, if you've ever driven behind it, there are transmission lines that spur out of it in all different directions. So it's a really central location and crucial for batteries to be able to pull electricity from different parts of the state there. Now, one of the talking points that I've been echoing here is that we're kind of on a steep learning curve with with battery fires. And we had a couple of fires over the course of the last few years, and um, our understanding of how important it is to have containment has evolved. And in fact, the battery storage facility in the turbine room that we're talking about that had the 300 megawatts of batteries that caught on fire, I don't think that, but I know for a fact that project would not be built today because we understand that you have to contain the batteries. You can't allow for spread. And it's very rare actually to have batteries inside of a building like that. So I want to also echo this point that it is a somewhat unique design. And in fact, because we went through a couple of fires in a short time period, we've developed standards now. Underwriter Laboratories has a standard for containment. It works at the first they look at the cell level and then the module level and then the racks and the entire system. And Moss Landing phase one, in the turbine room, the 300 megawatts, could not be certified to that standard. So that's really important because these underwriter laboratory standards they're not public policy per se, but they're crucial to insurance industries. And if you want to be able to have a facility that's insurable, you're going to have to meet those standards. And it's unlikely we'll ever see a building with batteries in it like we saw at Moss Landing because I don't think they would be able to get insurance for that. In fact, I'm not sure Vistra will have that all covered. I don't know the answer to that, but so that's, I think, really crucial is that, this standard came out in 2022. So we've been rolling out batteries, quite a lot of them since 2022, and they all should be built to that standard. And I think that's crucial because looking across the landscape, we would see containment looks a lot better in other facilities. Even, not just containment, but firefighting. We lost the cameras inside of that building. They're kind of looking blind, trying to fight that fire, where the outdoor ones, if you watch how they fight fires there, they just spray water on the adjacent containers to keep them cool, and that serves as another strategy to make sure that there's not that thermal runaway, which is that uncontrolled chemical reaction that happens when the battery gets damaged or if there's a little extra heat in there. So that's, I think, crucial, which is, the uniqueness of that particular facility, as well as the existence of standards that wouldn't allow for that particular design anymore. So I think that that's a crucial point here. Now, just a couple last points here. Moss Landing is an environmental justice community. So this is a community, as was intimated before, that's been exposed to pollution for a very, very long time. If we look at Cal Enviro screen, this is an overburdened community with smog pollution, particulate matter pollution that comes from that natural gas facility there that still operates. 50% of the area is minority households. There's a large portion of people who don't speak English who live within a 6 mile radius of that power plant as well, which speaks to the importance of making sure, one, that we retire the natural gas facilities there, but also that we have better strategies of communicating to the public about fires, about when should the evacuations happen, when there's a little bit of a delay between when the fire actually was happening and they thought it was under control and they actually ordered the emergency response. So I think there's a little bit of concern with the community that even though we had this battery safety legislation, SB 38 in 2022, that the battery operators didn't really react to it. And that's now why the California Public Utilities Commission, who regulates pipeline safety, transmission line safety, we've had fires from those too, right? In the past. So, having the CPUC step in here to make sure that the intent of SB 38, which is to make sure the communities are ready for fires and they have a way to react to them. I think that's a crucial next step is to make sure that we implement some of those things. And then the last piece I'll just add is that the communities, because of California law, don't have a lot of influence here because the approval of power plants in general can go over the head of local government right to Sacramento through the CEC opt-in process, AB 205. I think it's crucial that the battery industry doesn't utilize that. I think it's really important that they stay involved with local communities. Even if they do go the opt-in route, they still have to have a community benefits agreement in place. So they really need to have working relationships and they have to build trust with these communities. So and that means sometimes ensuring that the right resources are in place for communities and that. So I'll pause there because I think I've exceeded my time limit here, but thank you again.
No worries, Dustin. Thank you so much. And I think you're absolutely right. And one thing that I wanted to make sure that we covered in this briefing and the discussion that will follow is how battery storage companies can work with communities, with local governments, how that trust can be established and grown, and to make sure that everyone is educated, everybody is informed about not only the benefits of these batteries, but also the safety procedures that are put in place. So I do want to make sure that we pass to our next speaker, Nikhil Kumar, who is a program director with GridLab, where he works to accelerate the clean energy transition while ensuring grid resilience and economic growth. Nikhil, thank you so much for joining us today.
Thank you. And yeah, I appreciate the opportunity to talk to everybody. And Mark and Dustin, thanks for setting the stage. So I'll add some visuals to everything you all have said, and maybe add a little bit more context to my observations from Moss Landing. So I've been to that site before and after they transitioned to battery storage. Dustin, yes, I do remember it was oil fired and the combined cycle unit that's in its place now. And I've prior to GridLab, I spent 15 years looking at QA/QC of solar and battery. So I'm intimately sensitive to when you have a safety issue like this. It's easy for us to say, yeah, it's one-off, and in this case, it's a repeat incident, but it does have an impact. I mean, batteries are everywhere. If you all recall, we had a lot of these mobility solutions with batteries that came about maybe a decade ago, and they were catching fire. And that wasn't great. I mean, if your kid was riding one of those things and caught fire, it would have a significant, impact to your psychology. So, to me, this should have been avoided. Shouldn't happen. It has happened, so we kind of have to adapt and learn from this situation. And I'll kind of just walk you through some visuals just to give some perspective. So yeah, I mean, this is what Dustin and Mark were talking about. So on the left is what you see in Moss Landing. That's exactly what it used to look like in the past. And one of the reasons you kind of put these in buildings is you get higher density. I mean, if you were to put containers outside, you take a lot more space. You kind of concentrate everything. It kind of adds to the risk factor. If you do have a thermal runaway and you start a fire, it can have a significant issue. And coming to this particular incident, I think the root cause is still very important. We should wait and see what were the primary causes. Yes, there was an issue with the chemistry. If you look at the last couple of years, LFP is sort of the dominant chemistry that these batteries are using. The one that was used at Moss Landing was a little bit different. But is that the only reason why this incident happened? We don't know. So I think the root cause is very, very important. The safety incident trends, these are far and few in between. Comparisons to gas power plants or coal-fired generators will show that this is on a per terawatt hour basis. The number of incidents on batteries, at least on a utility scale, are insignificant. So that should be kept in mind when we think about that. There are some certainly once the root cause comes out, I think collaboration is super important. If you look at the statistics on failures or catastrophic failures like this, for the conventional fleet, NERC collects a lot of data. That's the Reliability Council within the US. But if you were to start searching for a database that shows you all the issues that we may or may not have with battery storage, it's a really slim database. There are a couple of nonprofits that are putting together information out there. EPRI certainly done some good work around that. But by and large, you do not have enough information on what are some of the issues that people are seeing. I mean, is it with the energy management system? Is it the chemistry of the battery? Is it the fire suppression system? There's all of these different things that can go wrong or might have gone wrong that is not out in the public. And so that collaboration would be very, very important, that we share that information. And we should really learn. So the Moss Landing facility is not decades old. It's, very recent, and standards have been evolving. As Dustin said, there are UL standards, there are NFPA standards, and we just need to continue to learn and adapt and share that information across the industry. If you look at a lot of the CNI installs, so when I talk about commercial and industrial installations, we need to make sure that their safety standard is up to the level of what a utility scale safety standard is. So retrofitting, where you may have realized that you built something to what was the existing standard 3 or 4 years ago and is not today up to the code, we have to put in the costs and the effort to bring it up to protocol. So that's my thought. I mean, just to think about these unique facility challenges of Moss Landing. I mean, we know that they had the stranded energy issue where the fire kept coming back. Industry will have to learn, and I have full faith in everybody involved that we will get past this. Just to also talk about what Mark and Dustin said, in terms of just economics, economics are at play. Today, if you were to go and build a combined cycle plant, it'll probably cost you pretty much, give or take, similar to what it takes to build a battery storage. Yes, combined cycle units can run for longer hours of the day, but from a capital investment standpoint, batteries are very much in play now, and I expect that to stay like that. And not just me, if you look at the EIA data set for 2025, you will see that after solar, we have about 18 gigawatts of expected batteries that will be added to the grid in 2025. So yeah, I think Mark said we have about 13.5 gigawatts of storage capacity in California. It was only 500 megawatts like 5 years ago or 6 years ago. So it wasn't a lot. We've come a long way. And California is doing great. If you look at PJM, which is on the East Coast, it's the largest RTO in our country. They only have about 400 megawatts of storage. So, the fact that California has taken a lead and has put in the amount of storage that we need is phenomenal. And, we should learn from what has happened at Moss Landing, but stay on course. And I'll just finish this up with like this couple of visuals for you. This is yesterday. I think Mark alluded to this, and I wanted to show you that yesterday evening so you can see we had 7.7 gigawatts of battery. So as the sun goes down, the solar is coming offline. If this battery wasn't there, you would have 7 gigawatts of natural gas that would come online. And not only that, natural gas would struggle to come online as quickly as storage does. So there's not just the benefit of the energy that storage is providing, it's how quickly it comes online, pretty much instantaneously to support our grid. And, we certainly believe, there are lots of studies out there. I just wanted to show you a couple of, charts. If we want to get to the California's goal of meeting even 85% clean energy by 2030, batteries are just important. They're just critical. We just cannot get there without this kind of technology being part of the mix. So with that, Jessica, I'll take questions.
Amazing. Thank you, Nikhil. These visuals are so helpful. And yeah, I'm really excited for a little bit of Q&A now. So we already have some questions submitted through the Q&A box. I will go ahead and share the first one that was shared. What can the battery storage industry do to build trust with communities like those who have been impacted by the Moss Landing fire? I'll open this up to anybody. I'm sure, Dustin, you might want to go first, though.
Well, I can, I mean, I was just listening in at a community meeting last night and was out there Thursday, Friday interviewing folks. And I think transparency is really crucial. And I don't know, I know we don't know the answers yet. So it's hard to be transparent when you don't know the answers for certain things. But it sounds to me, at least from the community's perspective, and I don't know if the developer would agree with this, but that the operator of this facility hasn't been completely forthcoming or transparent or present. Like for example, this was pretty widely advertised town hall last night in Salinas, and you got to send someone. If you're Vistra, you have to send someone to that meeting. I understand they're probably going to get a lot of questions that they can't answer, but I think you know you have to be responsible. Someone has to show up and be responsible to talk to field questions from this community because they have a lot of concerns and that maybe it's not going to be reassuring coming from the company, but it at least shows some level of commitment to the community that you're going to be present. So I think transparency is number one on all these things. And I'll just add the other thing, which was in my opening remarks, which is I think it's crucial that they continue to work, that developers work with local government. Because I think going over the heads of local government to Sacramento will just kind of reinforce the lack of trust with local government, local communities and such. So transparency and keeping all avenues of communication open with local.
Does anybody else have anything to add? I have a follow-up question. So yeah, I'm also curious, Dustin, do you have any examples of instances where that kind of community engagement or engagement with local governments has been successful that you've seen?
I don't want to punt on that because I'm not sure I have a good answer for that. I'll have I'm going to mull that one over because I feel like I should have a good example for that, but I don't right now. Certainly not in the storage industry, but it's we see this issue with even our utilities, right? PG&E causes wildfire issues, and there's generally it's hard. I mean, it's hard. Utilities have kind of a negative perception sometimes with the public, and this is people don't general people don't know how to differentiate like a merchant power generator from the electric utility. So they think they're kind of one and the same. So I think I think it's really difficult.
Okay, well, yeah, thank you so much. And yeah, this is definitely, it's a tough question to answer. So um, moving on to our next question. So every industry has an end of life. What would cleanup of a battery storage site be like? I've heard lots of questions of proposed battery sites becoming Superfund sites or being underwater with sea level rise. What does it look like at the end of a battery storage station's life?
I mean, I'll just pine in here. Well, batteries now are mostly recyclable and recycled. I mean, there are companies that recycle 95 to 98% of the material in the batteries. And so that's really the plan, is to take out the chemicals that are useful and reuse them and safely either recycle or dispose of the rest. So it's not, they don't just leave the batteries at the location and let them kind of over time dissolve into the into the ground. So they are, yeah, they're removed. They will be removed and recycled.
And I'll add to that. So, Redwood Materials might be who Mark's alluding to, one of these companies that's out in front leading on battery recycling technology. My understanding is they actually will take back and recover melted batteries. We had a battery, it was LFP actually, fell off the back of a truck, caused the highway to be shut down for for over a day. Department of Transportation had to hand out water to people stuck in the Mojave Desert. Um, but that ended up at Redwood Materials, from my understanding. So. But to that there's end of life battery issues, like what happens when the battery's done, and then there's like how do you clean up a fire battery, and that's probably a bit more challenging. This particular facility, because it was inside of a building, has a leaning wall right now, and it obviously caught on fire again last week. So it still has a lot of heat from that initial fire. So And this is part of what we're going to have to learn is we're going to have to come up with ways to put out fires. The strategy where the fire, talking to people, they're like, all the firefighters were hanging out at the coffee shop during the fire because they can't do anything. Like the strategy, which is, the best strategy they have is to let it rip because the more heat, the higher you can get that plume up. And unfortunately, that means more dispersion, but it also means less local smoke and less dangerous smoke for people in the immediate vicinity. Hydrofluoric acid is one of these chemicals we're concerned about from a battery fire, but it sounds like that fire was so hot that it was either consumed or went way up into the sky. So, but if it was a lower temperature fire, you might have more issues with that. So that's probably an area where we need some innovation, which is like, how do you put out a battery fire? And I'm not sure we have any ideas for that yet and what that looks like, but that's something we're gonna have to come up with.
Yeah, I'll just point out that if it's a small battery fire, they just douse it with a lot of water. But large fires, you just have to let it burn. And but otherwise, yeah, it's a lot. There must be a better way.
Yeah, thank you both. Another tough question, and your point about how we will need to learn from this incident, I think, is well taken. Mark, I know that you have to leave us pretty soon, so I am going to skip around to a question that I think is one that you and Nikhil can probably tackle. So Dan Jacobson asks, it seems to me that batteries are much more reliable than fossil fuel natural gas plants, not only on a day-to-day issue, as Mr. Kumar stated, but also when there are heat domes or other emergencies. Can anyone speak to the issue of reliability of batteries versus natural gas plants?
Yeah, sure. Well, first, a battery responds to a need within 20 milliseconds, which is basically the fastest of any electricity storage. I mean, even hydro, which is like a hydroelectric dam, I mean, it responds in like 15 seconds. But a gas plant responds in 300 seconds, up to it takes 5 minutes for to ramp up to 100% power. So batteries actually respond much faster than gas for meeting loads on the grid, which is really good. And you can then, in fact, I was charting data last year when there was the sun was hidden for a while. Remember when there was a, what do you call it, the eclipse? There was a solar eclipse. What filled in the gap for the solar eclipse when the solar output from the grid went down suddenly by 30-40%? Batteries kicked in right away to fill in the gap. And so they are extremely reliable. And, they are limited right now. Most of them are like 4-hour batteries, but which is good. But you can concatenate 4-hour batteries together, use one right after another. So if you have 2 4-hour batteries, you have 8 hours of storage. You have 3, you have 12 hours of storage. So we just need more and more batteries to fill in more of the blank spaces in California's grid when we don't have wind and solar operating. And right now, batteries are filling in pretty much mostly right after sunset, but they're also stringing along at night, at midnight, 2 a.m., 3 a.m., all the way to sunrise. And so the more and more batteries we have, the more we can fill in those gaps and make it much easier to match supply. Now, batteries are not the only type of storage that are growing. I mean, the largest kind of storage right now in the world is hydroelectric power. I mean, that's a big battery itself, but it's not going to grow very much. And pumped hydroelectric is the second largest in the world right now. And, that might grow a little bit more but not very much as well. So batteries are going to grow the most, but there's also pumped hydro storage. Maybe some hydrogen fuel cells can be used for storage, depending on if they grow very much. There's compressed air storage, but there's gravitational storage, like when there are some companies that they lift blocks using excess electricity and then they lower the blocks when they need electricity. So there are all sorts of technologies that are available, but batteries are the most convenient because they don't take up much space. You can put them pretty much anywhere. They respond really quickly and their cost is coming down. So now they're, depending on where you are in the world, their cost is making it so you can do it on a large scale, and they're being implemented not only in California, but also in Texas, has a huge amount of batteries, South Australia, but all around the world, we see more and more batteries going up.
Yeah, and I'll just add, thanks, Mark. I think, from a reliability standpoint, there's some couple of things that I'll point out. One, from a gas standpoint, if you look at some of the winter storms that have happened in the US, there were two reasons why the gas didn't perform. One, equipment on the gas plants would not perform. So if it gets too cold and you have some sensors that are sitting outside unprotected, you just can't run the gas plant. And second, you're competing with heating needs. So you might not just get enough gas to actually operate. So just from the standpoint of reliability, so not even considering the fact that you might be, just wear and tear on the equipment, under stressful conditions, gas might not perform. The other thing that's to storage's benefit is the distributed nature of it, right? You can put it pretty much close to where the load is, and it's very spread out. So with gas plants, they're bigger, more centralized. You have a point of failure there, you might lose 1,000 megawatts. In terms of batteries, they're spread out. If you look at the map for California, they're in hundreds of different locations. Also now, as I mentioned earlier, like the CNI installs are there. So you do have quite a lot of benefits with batteries, in addition to everything that Mark mentioned.
Thank you so much, Mark and Nikhil. I am going to turn us slightly to kind of go back to talking about how communities can best engage before new projects, battery energy storage systems are approved. So this question is from Hina. Can you speak more about AB 205 and that process of community engagement and how communities can get engaged with what's going on with the ESS facilities?
I'm happy to start with that. So AB 205 is what we call the California Energy Commission opt-in process. And, it essentially is reacting somewhat to concern that local folks are resistant to renewable energy or energy facilities or energy infrastructure in general. And one of the things that it does allow for, we're just seeing our first projects go through this process right now. I think that the Darden solar project right now is the first project that will have hit the milestone for having a community benefits agreement in place. But that's the key piece. So even though I said it's, I would be concerned if a developer bypassed local government, went straight to Sacramento for approval. The reality is they still have to work with the community in some way. So community benefits agreements are these agreements that allow for some kind of payments or some kind of some maybe it's a firehouse or not probably a bad example for this, but something that the community might need or and get as a direct payment of some kind for in as a result of approving a local project there. So it's not straightforward how communities actually get involved because the developers are the ones who have to come up with the strategies for local engagement and get feedback and work with local groups to figure out what those local needs are. It might be a couple $1 million payment to a nonprofit. It might be a couple $1 million payment to a county to help provide some services. Like I said, a fire department could be, one thing, and maybe that's something we want to be thinking about a little bit more, is making sure that where are these, especially in the context of batteries, like where are these emergency response places and are they sufficient for responding adequately for this? Because one of the things that we learned with this is when you have a fire like that, it basically uses all of the emergency services. Even though they're all, like I said before, they're all the coffee shop, they're still all there on site, and that stretches them. That stretches them, right? If there's another accident that happened at the same time, you need to make sure that there's capable and adequate fire engines and personnel to be able to respond to more than one at a time. So, but to answer the point about community engagement for 205, that as it's written right now, that's more on the responsibility of the developer to do the outreach and develop the plans, because as part of that process, they have to come up with a community outreach plan. And then once they have that community benefits agreement and the rest of the pieces in place, so the benefit to the developer is they have 270 days to get that thing approved, or within 270 days that project has to be approved. And that's one of the things that people are concerned about, right? Is it takes too long to build projects. So you could see, why that's important. So I'll stop there.
Yeah. So Dustin, I think the one thing that I would add to that is CPUC is still in charge, right? And so they can issue a certificate for public convenience. So there's a CPC, and there's a process where local communities can ask questions. So I think that's still there's a huge opportunity for communities to go and advocate for safety measures or understand more about these projects. So it's not happening in isolation, or there people wouldn't have an opportunity to actually raise any concerns.
So Nikhil, that actually leads to another question in the Q&A box, which is about the forthcoming PUC battery rules that are under consideration right now at the Public Utilities Commission. So Kathy Durbin asks, do you know what those battery rules will address? Don't the safety standards need to be in regulation and not just an underwriting standard for a certification? SB 38 deals with emergency planning and response, but we need more regulatory oversight. So I will open that up to whoever wants to respond, but in the same vein of PUC regulation, thought this would be a good follow-up.
I'll let Dustin get into the details and the weeds of the regulation that's brought up. I think Dustin made a good point about insurance, right? I mean, a lot of these projects would still need insurance, would still need to be able to raise capital to set things up, and none of the developers are going to keep on building these facilities without meeting whatever rules the CPUC ends up proposing. So, Dustin, perhaps you can add more flavor to that.
Yeah, so I mean, so part of the context didn't really explain this part, but we've been studying Moss Landing fires as part of an Environmental Protection Agency grant for the last couple of years. So that's why I was all ready to answer questions when the big fire happened there. And the way we had been thinking about that before was the earlier fires and how that got SB 38 into motion, like how that got developed, this legislation that would have some sort of community response, emergency response. And my understanding is that a lot of that wasn't really implemented. A lot of developers didn't necessarily come up with emergency response plans. So the CPUC integrating SB 38 into their rules is really an effort to bring some oversight into that emergency response. So we'll have to see. I think there's other reporting requirements, like if there's incidents, they have to report. I haven't fully read the whole bill, or the whole rules yet, so I'm still learning a little bit in there. But that's one of the key things, because I had been thinking about it earlier as, that there was the earlier fire that was the PG&E Elkhorn fire, the other battery that's on site, and how that prompted emergency response legislation, but it didn't really prompt a reaction from the developers. And I think, I forget which of the developers on site had said something like this, but they didn't even realize it was supposed to be a public document, for example, the emergency response. And that's, I think, crucial that these things are public documents, and that we, that the emergency responders know, because at the end of the day, I mean, this project was signed off by the fire chief, the Moss Landing, and that goes to like why where the state maybe could play a role is bringing in more resources to local government to make good decisions about signing off. This has a ton of experience fighting fires, unfortunately now, that over there at that Moss Landing site, but he maybe not prepared to be signing off on something where you have to know a lot about the standard, you have to know a lot about battery fire containment, and firefighters have other things to be training themselves on, not necessarily every particular battery type or every particular incident type.
Thank you, Dustin. Really appreciate the context around the PUC's proceedings. So we are running low on time, but I am seeing kind of a theme in the Q&A box that folks are wanting to know about kind of the nuts and bolts of battery storage. So how are batteries made? How are they sourced? What causes repeat fires like we've seen at Moss Landing at a battery storage facility? And then to kind of lump that in with our earlier discussion, what are the impacts of environmental impacts like weather? How do we protect and shore up battery storage facilities? So yeah, I'll leave it there, but that kind of addresses a few different questions.
Well, I mean, I could speak a little. I don't know what they're going to do about the contamination issue. You know, they had citizen scientists out there collecting heavy metals. We have actually a research scientist at Moss Landing Labs who also collected data on the spread of those metals and how those will be cleaned up. It's unclear because they're kind of, you know, very, very dissipated across a large area. I think there's questions around, you know, what does like runoff look like? I mean, this building no longer has a roof on it, right? And that fire, you know, when it rains, we got, you know, notice from Monterey County, a potential flare up because adding water into these batteries after a rain event could cause it to flare up. So I think there is a little bit of need to make sure or assure the public at least, and I'm not, this is where maybe the company's doing the right thing, but the public has questions around like whether or not potential metals and plastics runoff from the actual fire, is that being adequately contained on site. And I saw something about Superfund site here. That site is actually partially a Superfund site already at the Moss Landing. I mean, they had, you know, part of where the batteries are, they used to have oil tanks for the oil we mentioned before, and that has left some legacy contamination there too. I'm not sure I answered all the questions. I forgot all the questions that were built in there.
So we're also wondering about the nuts and bolts of how battery storage facilities are, like how the materials are sourced and how, yeah, what are batteries?
Nikhil, you want to take that one?
Sure. I mean, there's different ways of putting together a battery storage site. So, you know, you can think about it at the residential level, which is one way, and then utility scale. So there are companies that manufacture the full stack, so to say. So they'll manufacture the battery itself, and they'll pick a certain technology or chemistry from, you know, based on their own work, and then they'll build out the entire system. And there's a lot of other things along with just the battery itself. I mean, there's DC batteries, AC batteries, there's, you know, inverters involved, there's energy management systems involved. So it's not as trivial as just putting a small piece of equipment in a containerized setup and connect to the grid. So lots of different things happen. One way is you build everything yourself. The other one, and I won't name any companies, that they would go and source, you know, they will ask what is needed. So if they want to build a 100-megawatt site, the you know, whoever the buyer of the power is, they'll provide them with some technical requirements of what the battery is supposed to do, how many years should it last, how would it operate, like is it supposed to operate for 4 hours? Is it supposed to operate for 2 hours? So there's all of these different things that they have to think about. And you could just go and procure any kind of battery. So you don't build everything yourself. You go to the open market, or you have certain vendors you normally work with, and you would ask them to provide with, you know, you'll provide them with a bill of materials, and you'll go and acquire a certain kind of cell technology. We've seen sites where, you know, you may not have a single vendor battery at the same site. You might have a mishmash of different manufacturers at the same site. There are some tier 1 suppliers, tier 2 suppliers. There's a whole series of supply chain and quality of suppliers that are available. And I think I made this point, and I think everybody on the panel made this point, is that, you know, batteries are getting cheaper. Just to give you perspective, the US and Europe are about 30 to 40% more expensive than some other parts of the world, right? So you know, if you're just thinking about the price of battery, it's going lower. that doesn't necessarily mean that a cheaper battery is of an inferior quality. I think it really comes down to scale and the supply chain that you have. So I don't know, Jessica, if I answered the question completely, but it's no standard way, right? I mean, there are best practices and then there are practices. So that's how it's modular. You kind of it's like a Lego system. You put everything together, and then there you have it. You have a battery storage system.
And I'll just add one piece to that, which is that unlike a car, which when you're driving it, the air helps cool the battery. With stationary storage, you do need cooling for these facilities, so you have to have externally applied cooling onto these, and then you also have fire suppression. And these are pieces that you don't see in vehicles, but they're crucial for batteries. Now, I think that we're probably going to see, and this isn't in standards or anything yet, but I could see people making the case that we need to have more redundant fire suppression. Because once you lose your fire suppression, you don't have any other way of putting that fire out. And I think the thing to keep in mind with Moss Landing's fire is that battery was pretty contained to one battery or set of batteries for 2 or 3 hours before it went off and took all over the rest of the building. And that is the opportunity to really keep it contained. And that goes to show, like, if there was proper containment, it probably would not have spread and gotten anywhere near the size. So, I've been saying I think that's going to be the biggest battery fire in the world that we ever see in that facility, because I think anything that's similarly designed will be required by their insurers to retrofit the facilities. And I also can see maybe there's more opportunity to build in fire suppression redundancy. I mean, that's when you saw the headlines from this in the first couple of days, the 3 Mile Island event for the storage industry, which I didn't read that as contamination and toxicity stuff. It was more about like safety and redundancy and building all of that safety and redundancy into the design of the facilities. Now, I think that's where really what we should be addressing is like, okay, how do we make sure fires don't spread? We put the fires out, we keep them small, and that's really going to be the solution to this, because it's probably unlikely we'll be able to stop all battery fires, but we can sure keep them small. And there's 100,000 batteries in that facility, and we could have kept it to a couple hundred or fewer than that. So I think that's what we're looking at in the future.
Yeah. And Jessica, one thing, and Dustin, that makes complete sense. The other thing to keep in mind is most of these facilities are not manned by hundreds of people. Like, I mean, a conventional power plant, if you thought about a coal plant, you might have 1,000 people on site. A lot of them trained to take action under certain circumstances, like a fire or a leak. That's not the case with battery. You might actually have a set of people watching multiple sites miles away from each other. So that's why you're sort of so reliant on the fire station, right? So you can't really do anything.
Thank you, Nikhil, and thank you, Dustin. We've got about 4 minutes left, and I want to make sure we get to one question about NIMBYism. So how do we combat NIMBYism around battery storage facilities? How do we communicate with community members that these facilities are not like gas plants that are sited in communities and don't have that kind of toxic legacy? So if you can both respond in maybe about a minute, after that, I'll close us out.
I think that's hard, and I don't know what the solution is there, because you will probably have communities that take advantage of these accidents to push back on anything that's proposed in their area. But at the same time, maybe there is opportunity for battery developers to work with communities for projects that are controversial, like seeing these fires. Um, you know, do I want a battery facility sited next to a hospital? I'm not sure I do. I mean, it's pretty hard to evacuate a hospital and all these things. So I think, there has to be a little bit of openness to the developers, that they have to work with communities to figure out the best places. But I think you hit a point, which is it's very difficult to differentiate intent there. Does the community actually want the battery? Are they trying to work it in a safer place, or they just don't want the battery at all? And I think that's a tough one. That's what we're gonna be working, to try to resolve that over the next however long as we build out the system.
Yeah. I mean, great points, Dustin. I mean, from California's standpoint, I just recall when we were working on putting smart meters in residences' homes, I mean, there was a lot of reluctance to that. Come 2025, and this is, it took a decade, maybe longer, and now we have 70% plus homes, residences that have smart meters in their homes. So it'll take time. It'll take a lot of education. It'll certainly take effort from the industry to make sure that we, set a good example. We don't want another Moss Landing. So that's all I would say. So it'll take time, but we'll get there. We have almost 14 gigawatts of storage. That is commendable.
Thank you so much. We are out of time, unfortunately. And there are still some questions in the chat that I would love to answer. So I will do my best to maybe facilitate some emailed exchanges after this. And I will also make sure that everyone who attended today's webinar will get a copy of the recording. Thank you again for attending. This has been a really great discussion, and I'm really hoping that this can continue. Please don't hesitate to reach out to me with any more questions, and I will do my best to answer them. Ted, I see your hand. And because we're out of time, I will reach out to you after the webinar to see what I can do to answer it. Thank you all, and hope you have a great day.
Thank you.